Section 4.4.3 Polar Form for Leaving Cert Maths Higher Level Only. This video was produced by the UCD Math Support Centre in conjunction with the UCD Access Centre. So we say a complex number is in polar form if we write it in the form z equals r cos theta plus I sine theta. We're used to seeing complex numbers in the form x plus iy. So r is the modulus of z, which is equal to the root of x squared plus y squared, and theta is the argument of z, and it's the angle between the line to the point and the positive x-axis when you draw your point on an argand diagram. So let's take a look at an example now of how to calculate that. So example 1, write 1 plus I in polar form, i.e. in the form r cos theta plus I sine theta. So firstly we need to plot our point on an argand diagram. So let's do that now. And let's draw a line from the origin to the point and mark in theta, which is the angle between the line and the positive x-axis. So remember that r is the modulus, so the modulus of 1 plus I, which is the root of 1 squared plus 1 squared, which is root 2. And looking at our diagram, we can see we've got a right angled triangle. We want to find theta from our diagram. We can say the tan of theta is 1 over 1. So that's just 1. So then theta is the inverse tan of 1. And so theta is going to be pi over 4 in this case, because we choose a value of theta between minus pi and pi. Therefore, we can say 1 plus I is equal to root 2, which is r, times cos pi over 4 plus I sine pi over 4. Example 2, write minus 1 plus I root 3 in polar form, i.e. again in the form r cos theta plus I sine theta. So again, let's plot our point on an argand diagram. And again, let's draw a line up from the origin to the point. Now this time we mark in alpha, which we call our reference angle. And then we want to relate this back to theta, which is the angle to the positive x-axis. Remember, the positive x-axis is the part of the x-axis to the right of the origin. Now in this case, r is the modulus of minus 1 plus I root 3, and that turns out to be root 4, which is 2. Let's find alpha. The tan of alpha is root 3 over 1. So alpha is the inverse tan of root 3, so it's pi over 3. And then looking at our diagram, we can see theta is pi minus alpha, so pi minus pi over 3, so it's 2 pi over 3. Therefore we can say minus 1 plus I root 3 is equal to r, which is 2, times cos of 2 pi over 3 plus I sine 2 pi over 3. And we're done.